In part 3D, we are going to discuss bank armory. We begin with a straight channel that has a length of 171 centimeters, an S-box of 3.536, and an S-max of 0.019. We began discharge at 55 milliliters per second, and as you can see, the channel began braiding. In order to create the meandering channel, we eventually kicked up the discharge to 66 milliliters per second, at which point a cutoff channel was created. Eventually, upward extension of the headwater channel from groundwater sapping linked our two channels together, creating our full meander. Our forward meander has a channel length of 216 centimeters, a sinuosity of 1.26, and a slope of 0.015. This is where our riprap experiment began. Riprap along the first cutbank to prevent cutbank erosion, as well as we put a man and a house behind it to qualitatively decide how well the riprap performed. The extent of the riprap and the man and the house are seen here. You can also see what we decided to be the extent of the man's lot. We began again with a discharge of 55 milliliters per second, but shortly after had to stop after a crevasse splay formed and an earthen dam was unable to prevent the stream from forming. To prevent this from happening again, we added a second portion of riprap, but we also decided to extend the terrace further downstream. And here you can see the extent of our riprap. With this addition, we believe that our flow would follow the orange line as seen in the video. Once again, discharge was set at 55 milliliters per second. Here you can see a meander extension as well as a neck cutoff. The restriction of the channel created by the riprap created further complications. As you can see here, there's flooded riprap as well as scouring created by increased velocity of the foul wag. At this point, blue dye was used to help indicate where the channel was. In this freeze frame, you can see the position of the foul wag after 10 minutes. Before continuing, we decided to reinforce the riprap that was currently positioned. This was followed by increasing the discharge to 55 milliliters per second, whereby we can start seeing some of the issues that arise from riprap. A large upstream cut bank forms, as well as irregular meanders form downstream. Discharge at 110 milliliters per second creates a large meander lobe created by the impermeable surface of the riprap. Decreasing the discharge to 55 milliliters created further irregular meanders and made it rather difficult to find which channel to measure, so we decided upon these two shown. With portions of both of our riprap additions relatively flooded, we decided to create a new one upstream to maintain the channel we have created. Our new addition of riprap is shown within this orange circle. For the last time, we increased our discharge to 55 milliliters. At this point, you can begin to see scouring occurring at both segments of the riprap, as well as you can start to see our lower downstream riprap begin to fail. When discharge is increased, it completely fails. After 27 minutes, the man has fallen in the water, and rapids are created where the old riprap has fallen in the water as well. Even more so than before, there is intensive scouring occurring within the channel. Our last foul wag is indicated by the light blue line. Our channel length ended at 203 centimeters long, a sinuosity of 1.19, and a slope of 0.016.